Hi, Chem Peeps. We're continuing our final exam review for first year chemistry. We're going to talk about bond types today. And on the left side of the screen, you can see I have some charts that I had in my notes with my students. The first chart are electronegativity differences that help determine the bond type. Now, if the difference between electronegativity is between 4 and 2. Now, this is not the exact one I have from my book. In fact, the one from my book is 1.7 here. But there's another way to tell when you're that close to the border, and I will explain. But if you're between 4 and 2, it's going to be an ionic bond. Between 2 and 0.5, it's going to be polar covalent. And between 0.5 and 0, it's going to be nonpolar. And then below here, I have a chart of electronegativities that came from our book, which we will reference. So let's look at the questions that I have on my exam. Remember that you have a year's worth of exam that must be assessed over a very short period of testing time. And so the teacher needs to be selective and wise in how they do this. So 37 says a metal bond to a non-metal, a metal bonded to a non-metal will form what type of bond? So yes, we can objectively calculate using electronegativity differences, but I also tell my students that ionic bonds form between metals and nonmetals. There's a transfer of electrons, and then you have a cation and an anion, and that is going to be ionic. Covalent, whether it is polar or nonpolar, is going to be between nonmetals and nonmetals, and they share electrons to get an octet. And so that's the very difference between them. And so if it's a metal with a nonmetal, just in general, it is going to be ionic. 52, a polar bond occurs when? Okay, so a polar bond is this section right here. And they're sharing to get an octet. And so let's look at our choices. A, two atoms, it's supposed to be with, not will, with an electronegativity difference between 0.5 and 0.2. This is a yes, but let's just check the other ones. Electrons are transferred. No, that is ionic. C, two atoms of the same electronegativity bond. No, that would be nonpolar. And D, electrons are shared equally. No, again, that would be nonpolar. So the answer here is clearly A. 53, anionic bonding. Okay, so with ionic bonding, we're now up in this section. In ionic bonding, the electronegativity between atoms is greater than 2. Yeah, that's true. Let's see about the other ones. Electrons are equally shared. No, that's nonpolar. Protons are transferred. No, we don't transfer protons. We transfer electrons in ionic bonds. So that's a trick question there. And D, there are no more than 2 atoms. That doesn't relate to determining bond type. Okay, so answer is A. 54, sodium and bromine would form what type of bond? Well, first of all, sodium is a metal and bromine's a nonmetal. So if I felt confident about that, I would say covalent. But I could check. So if I check the electronegativity differences, sodium is a 0.9, and I get that right here. And bromine is, don't have my glasses on, 2.8. So, this gives us a difference of 1.9. And you might be thinking, that's there. But remember what I said, in my class, my book is 1.7, and we also have this to help us make this decision. It is covalent. Okay, 55. Which of the following is a formula unit of an ionic compound? This is the application of some vocabulary, so let's talk about it. Ionic are between metal and nonmetal, and they form formula units. They form crystal lattices. Covalent compounds are between nonmetal and nonmetal, and they form molecules, individual molecules. So we're looking, does the student understand the difference between these bonds and the nomenclature? Formula units means I'm looking for ionic. I could, for all of these choices, I could do the electronegativity difference, but I'm going to go with my definition of ionic being a metal with a nonmetal. So A is hydrogen with chlorine. That's a nonmetal and a metal. Or I'm sorry, it's a nonmetal and a nonmetal. Even though hydrogen's on the metal side, it is not a metal. Water and oxygen, or water has hydrogen and oxygen, 2 nonmetals. Carbon and oxygen and carbon dioxide, 2 nonmetals. But here, D, cesium is down here and chlorine is over here. That is going to be your ionic compound that has formula units or crystal lattices. 56. Which of the following is not a molecule of a covalent bond? In other words, we're looking for ionic again, and we want a metal with a nonmetal. Yes, you could do the electronegativity differences, but I'm just going to see if I can differentiate just with this definition. Lithium and oxygen, that's a metal and a nonmetal. Hydrogen and sulfur, 2 nonmetals. Carbon and oxygen, 2 nonmetals. And carbon and sulfur, 2 nonmetals. So I'm just going to go with A. 57. Given the electronegativities, hydrogen a 2.1 and chlorine a 3.0, what type of bond would they form? So 2.1 minus 3.0, absolute difference is going to be 0.9. That's going to be polar covalent, and so I'm going to say B. All right, so there's my review on bond types. Give me a like, share, save, or even leave me a comment as to whether this helped or you need more information. Good luck on your final. I'll see you on the next video.